Hello everyone, welcome to this video where we are going to dive into longest square straight in an array. So what is happening here is that you receive as input an array of integer. I am supposed to find out in that array what is the longest subarray in such a way that each of the elements starting from the first element, element at position 1, is actually equal to the square root of the element before him. You can see here the square root of 4 is actually 2, which is the element before 4. The square root of 16 is actually 4, which is the element before. So you are supposed to find out what is the longest subarray that you can have respecting this condition. Okay, and if you don't have such subarray, you return -1. Keep in mind that a subarray with length 1 is not considered a valid solution because you need to have at least 2. So now that we know what we are supposed to do, how can we solve it? This is a thought process I will share with you. You will tell me at the end of sharing the thought process, we are going to decide what are the data structure we are going to use to implement. So the idea here is that, okay, I have my array initially like this. I want to keep it sort. So I want to have the array being sort like this in a data structure. And when having the array like this, I want to take the smallest element in my array and I want to loop. I want to take the smallest element and consider it as the beginning of a subsequence. And I will say, okay, is the square root of that element in my list? If it's the case, I increment my subsequence and I consider now my element as this one. I will move, is the square root of this element in my sequence? Yes, it is. And at the end of this operation, what I need to do is that I will delete all the elements that I took and I will keep the size that I obtain. Because why am I removing 4? I'm removing 4 because all the sequences starting at 4 will actually be smaller than sequencing starting at 2. So that is why after taking 4, it's okay for me to remove and consider an array with no 4 in it. Okay, so after this, I will repeat. So this is actually the solution 3. It tells me that I can have a subsequence of 3 elements respecting the condition. Okay, I remove the element. I will start back. I will take now the smallest one. I do the same. I have 9. I don't have 81, so I will stop. This is a solution of 2. This is a solution of 1. Since 1 is not a valid solution, is 0. This is a solution of 1. Since not the valid solution is actually 0. And at the end I return the biggest among those elements, which is actually 3. So what would be the best approach to solve this? For me, to implement what I just described here, I will use a double while loop. So first, instead of sorting, I'm going to put in a set. The set will automatically sort and it will make it easy to find an element. So I will use a set for this first. And after using a set, what I will do is I will say while the set is not empty, for each of the step, I will take the first element of the set and I will loop searching for the square root of that element. If I don't find the square root of the element, I will break and I will compute the sum of the element I found so far, and that will be all. So let's implement what I just described. So the first thing I said is that I will have a set. It would be better to have a set of long. I will explain to you why. Let me explain it now. The constraint is saying that you can have at most the biggest value is 10 power 5, right? But don't forget that when you're taking an element, you are squaring the element to find the next element. And after squaring the element that you have, if you have like maybe 10 power 4, the square root is going to be 10 power of 8, which is above what int can support. That is why it will be good for you to, not here, it will be good for you to have this in long. You may argue that, oh, but what we have initially is num of I. Yes, it's num of I, which is actually in this range, but you are going to take element with value that may exceed this range to find in the set. That is why it's better to have it this way. Okay, so I'll call it numbers. I will say num dot begin and num dot end. And then after this, what I will do is that I will create my ans, which is actually initially as -1, because if I see nothing, it will be -1. I will have my double while loop that I said. The first one is while numbers dot size, and in the while loop, each step of the while loop is actually a step of moving from the smallest till all of the sequences starting at that smallest. So how do we do that? I'm taking long off. First is actually equal to I'll take the first one is numbers dot begin. I have my first element, and I'll just create a sub here, which is actually equal to 1. That means it's the number of element of the sequence. Okay, so now that I have this, it's okay for me to erase the first one, the element that I took, right? So I can erase. How do I erase? I will erase with number dot erase of first. This star is just to show that I'm taking the value, because number dot begin is actually a pointer to the first element, so the star is actually the value. Okay, and then once I have this, I need to have now my second while loop with a strange condition like this: while numbers dot find of first dot first is actually different from numbers dot end. So while the square root is in the array, I'm going to increment my counter, and after incrementing my counter, I remove the square root. That means the element that we just found as a square root, and after this I will just say the first is not taking. Now you understand better why I define this as a long, because what I'm searching here, this value that I'm searching can be something really big, and for this one to handle really big element, this one needs to be a long, and if this is a long, it makes sense for me to have this as a long. And then now after this, I need to check if the sub is actually greater than 1. Then I will say ans will now take the max of ans and sub, because if it's a 1, it's not a solution for us, so we don't count that. And then here we just need to return our ans. Let us run. Working. Let us submit. Perfect, it's working. So this was my approach of solving this. I hope you do enjoy it. Feel free to give me any input. I'll be really happy to interact with you regarding this. See you tomorrow for a new challenge. Don't forget to like, share, and subscribe. Ciao.